But what we're going to talk about tonight is this idea of sampling frequency distributions and then some graphs that go along with that. Sampling is really important when you're trying to take down, well, you do it for a lot of different things to get data for things. In particular, for instance, people use sampling for finding out like who's ahead before an election, right? What they do, anybody get those calls, right, at home where they're like, who are you going to vote for? Right? Normally you just slam the phone down on them, or you like, you know, tell them to go whatever themselves and then slam the phone down, right? But the sampling is all about collecting all this data and then doing something with it. Okay? In particular, you're doing something that tells you something about the population that you've got all this data for. Okay? So we've got some vocab here. Okay? Just a few pieces of vocab here. When we're talking about sampling and distributions, we've got the population, which is exactly what it sounds like. It's all the different, it's the group that the data is about. Okay, the population is the data itself, or it's actually a subset of the population can actually be what the data itself is. Okay, so that's the population. All people or objects whose properties are described by the data collection. Okay, all people who own cars, right? That's a population. All people who are stationed in Djibouti, that's a population. Okay, all right. A sample is just a subset of that population. Turns out you can't ask every person in the country who they're going to vote for. It's just impossible. But the cool thing about this branch of mathematics, called statistics, is that you can, using a small subset, you can actually determine broad properties for the whole population. Okay? Not individual ones, but you can do broad properties. So you can say, so-and-so is probably going to win the election, or not. Okay? The sample is just a subset, and it can be a tiny subset or a large subset, depending on how much you can actually do the actual picking of the data. And then we have this idea of a random sample. So a random sample is a sample for which every element has an equal chance of being selected. Okay, that's a really important part of this. Okay, I don't know if you guys ever remember seeing a picture like in history class of, I think it was Harry Truman, holding up a paper that says basically the other guy won, and it's the day after the election. It's like a newspaper that says the other guy won when actually Harry Truman won. What happened was they did all this polling, they picked all these data points, right? And they figured out that Harry Truman there's no way he was going to win based on the polling they did. And so this newspaper decided to get a little bit ahead of the game and printed the results for the other guy winning, and turned out to be completely wrong. Well, what had happened was they didn't have part of the reason was they didn't have a random sample of people. They picked only people who had telephones or whatever it was back then. This was 1946, I guess, something like that, right? And they only picked people in a certain category. They didn't pick through a whole vast population of people who could actually vote. And so they got a skewed results. The results showed that they were all going to vote for the other guy, right? And so they thought the other guy was going to win. Well, the people they didn't pick happened to be it wasn't a very good random sample. And so, you know, Harry Truman ended up winning. So you've got to be really careful that you pick a random sample. Every element has an equal chance of being selected. Okay? And the method of choosing that random sample is kind of the important part. You can't just say, let's say in this class, if I just said, I want to pick 5 people, and I just went the first front row, right? That's not a random sample, right? The only way you could do a random sample was, let's say, well, there's lots of ways, but let's say I had all of you guys put your names in a hat, and then I picked 5 out. That's a random sample. Picking the front row, right? I mean, what if the question was, do I write big enough on the board? Everybody in the front row goes, yeah, you're right, you know, big. But all you guys in the back are like, you know. So that wouldn't have been a very good sample for that question. OK. All right. Anybody still writing these things down if you're doing it? Remember, this is all online. You can get all this stuff online. OK. So the next thing we're going to actually talk about is this idea of a frequency distribution. So once we have that sample that we've picked the right amount of people or whatever we're doing, okay, we need to summarize it somehow. We need to show that data somehow. Okay? Each element in this frequency distribution Okay, each element, okay, is called a data item, or a datum, I guess sometimes they call it that. Okay, so here's an example. Let's say we went and measured the heights of 10 men. Okay, 10 men, and here's our data set. Okay, this is in inches. Okay, 68, 73, 69, 70, 73, 70, 67, 70, 66, 72. Okay, and this is all in inches. Okay. We've got to somehow put that data in a form that makes it a little more easy to deal with. Okay. What we do is we put it in what's called a frequency distribution. Okay. We have, let's say, 2 columns. Do it like this. 2 columns, like that. Okay. And what we'll do is we'll have the data values and the frequency. And the frequency is how many of whatever data values we have there are in our sample. Okay? So let me write down all the different ones that we have here. We have a 66, 67, 68, 69, 70, 71, 72, and 73. And I think those are all the ones that we have. We don't even have 71. I'll put it in here to make the chart work out all right. But if we go from 66, I should have said the minimum and the maximum, 66 to 73. Okay, we're just going by ones. OK, how many 66s do we have? 1. 67s? 1. 68s? 1. 69? Also 1. 70? 1, 2, 3. Yeah, 3. 71s we said were 0. 72s, 1. And 73s, 2. OK, there's our frequency distribution. OK? And hopefully, these numbers add up to the total, which is 10. Right? Because we said, out of all these, we've got 10 samples. Well, if we list them all here and count them all up, there should be 10 of them. OK? Sometimes, if we have a large number, OK, then sometimes it would be hard to do all this out. Let's say we went the height of all people in the world, right? You'd go from like babies, which are like, what, 10 inches, right? All the way up to the tallest guy in the world, which is 90 inches or 85 inches or whatever he is, right? And that would be really hard to read. Sometimes we just break it into different chunks, right? We might say, for this data, this isn't a big enough chunk to worry too much about, but let's say we went 5 foot to 5 foot 11, 5 foot 11 inches, right? Well, what's, let's see, what's 12? Sorry, not 12. What's 6 feet is 6 times 12, 72? No. 70. 6 foot is 72. 6 foot is 72 inches, right? So let's do all the people from 5 foot to 5 foot 11. That's this many, right? So it's going to be 3, 4, 5, 6, 7. So we would have 7, and then 6 foot to 6 foot 11 inches. And then we have 3. So we could break it down into a different chart like that if we wanted to, right? We wouldn't really, for this data, it doesn't make too much sense to do that. Okay? But that's how we do these frequency distributions. Okay? All right. If we're going to do those breakouts, by the way, you want those to have the same width. In other words, you don't want to go 5 foot 1 to 5 foot 3, and then 5 foot 4 to 6 foot, right? Because that would have different widths. You know, there'd be only 2 categories here and like 7 categories here or something like that. You don't want that, right? You want them to have equal amounts in each bucket. If you're going to throw them into the buckets for how high they are, you want each bucket to have the same amount of space, basically. Okay? All right. We can do this in a different way. We can actually make a graph of this, which we call a histogram. Okay? We can make this thing called a histogram, which is which is a graph which shows each one of these frequencies, and on the bottom has the data. So it looks like, for this, it would look like this. Okay? It would look like, let's see, we would have 66, 67, 68, 69, 70, 71, 72, and 73. And it's kind of like a bar chart or a column chart, if you will. Okay, so let's see. The maximum we have is 3. So let's make 1 be here, 2, and 3. Something like that. So 66 would be 1. So you can make a little block like that, right? 67 would be also 1. You might want to make these different colors if you have colors. 68 and 69 are also 1, like that. 70 is 3, so it's like that. 71 is 0, so it's not at all. 72 is 1 again. And then 73 is 2. So there's your histogram. Not a very good histogram because we don't have enough data. If you were to take all the people on Camp Lemonnier or something and add them all up, you're going to get much better ranges here. Okay? And in fact, if you take everybody on camp, you'd probably get a really cool curve, which we'll talk about a little bit later, called the bell curve. Which would look very cool on this. Okay, but we'll get there. Okay? And then you want to label it. You want to say the height in inches, and you want to say the frequency or something like that, just to label it. Question?
So is the histogram just a bar graph?
Yeah, it's basically just a bar graph, but it comes from this data and the frequencies of the data. Frequencies being the amount of people in each category. Okay? All right. We also have this thing called a frequency polygon. Don't worry about what that actually means. Let me erase this right here. A frequency polygon for this is basically I can do it right on here. It's basically the exact same thing, except you don't put a little bar. You just put a little dot right above it, like this. 0, like that. And then you connect all those dots. I'll use yellow because it's a color I can see, right? You would connect all the dots like that. And then you would get rid of the bars. So it would just be a graph like that. You might see something like that on the quiz. It's just a different way of representing it. It looks almost like a bar chart, except there's no bars. It just looks like a line graph. And it's the same exact thing, though. Just connect the middles of all the dots. Okay? Sometimes we can also do this slightly differently in this thing called a stem and leaf plot. And I'll show you why it's called that in a second. Okay? A stem and leaf plot is another way, it's kind of another fancy way of making this data show up in an interesting way. Okay? What you do is you actually take the, you take the number here, like let's say you have 66 to 73 like this, okay? And you would actually have stems and leaves like this. And what you do is you take the first digit, okay? So there's only 6s and 7s for this one. And then you count how many of each one you have in this column and write that many of the second digit. So this would be like 66, 67, 68, 69, because there's one of each of those. Okay? And then 70, there's actually 70, so it'd be, there's 3 of those. So it'd be 73 zeros. And then 71 is 0. 72 is 1, so you'd go 2. And then 73 is 2, so you'd have 3, 3. It's kind of another way of looking at this. This one doesn't show that many, okay? But I tell you what, I'll do another one right below it here that might show you a little bit different. In fact, if you just saw the stem and leaf plot, let's say you saw one that looked like this. Stems and leaves, like this. 4, 5, 6, 7. And it was 2, 3, and 5. Let's say there are no 5s. 6, 8, 9, and 0, 0, 0, 2, 3, 3. Actually, it is the same one here. I guess it's the same data for this one. 51, 1, 1, 1, 1. How many people are 51 inches tall? 5 are, right? How many are 50 inches tall? None. How many are 52? None. You get it? How many are 68? 1. How many are 70? 3. Yeah, because that's 70. OK, so you get how these ones work now, right? You will rarely see this, but it is just another way to kind of flesh out this to give you a little bit more of a visual picture of it. A little bit more of a visual picture. OK? All right. That was actually all of 12.1. Pretty quick one, this one. OK? All right. 12.2 is something I'm sure most of you have actually heard about if you haven't actually studied it or not. OK? And you might not have heard of this name for it. This is actually 12.2 is called measures. Whoops. What was that? Measures of central tendency. Measures of central tendency. OK? Here's what that means. And when we get to the actual ones, you'll go, oh, yeah, I've heard of that. OK? The question is, what is a normal, typical representation of a data set? OK? So if you were to say, you know, how tall is everybody on base? Right? What's the kind of the right answer is, well, we're all different heights, right? But could we say one number that would give at least, like if Martians came down and said, how tall are people? Could you give a number that would at least tell them something? Yeah, what are you're like 5'5" or whatever, right? What is that number probably? An average, right? That's what we're talking about when we're talking about measures of central tendency. OK? American men are about 6 feet tall, I guess, on average, right? And using on average is, we will make that explicit what we mean by that in a little bit. OK? But we use 3 different measures to talk about this stuff. OK? We use the average, which we don't call the average in here, although you can use that term if you want. We call it the mean. OK? The mean means the average. OK? Do you remember what the other two are? Anybody who's done it before? Median and the mode. So we've got this other one called the median. And there's a third one called the mode. OK? And mean and median are different, even though sometimes they sound like they're the same term. They are different. And we'll talk exactly about what they mean. OK? First of all, let's do the mean. OK? The mean, we actually designate the mean by doing x with a little bar over it. That little bar means the mean, or it means the average. OK? Also called the average. Mean or average. OK? If we have a data set that looks like this, 13, 13, 14, 14, 15, 16, 16, 17, 17, 17. OK? Yeah. How do you find the mean? You add up the number of items. OK? So in this case, there's 10 items. OK? If you add them all up, you count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. OK? You add them all up. OK? Then you add them. OK? You have to add 13 and 13 is 26, plus 14, et cetera, et cetera. You add all those up. You actually get, for this, I think you get 152, if I did my numbers right. OK? And then you divide the sum by the count. OK? And you guys have all done this before. Divide sum by count. Terrible handwriting. Sum by the count. OK? So in this case, it's going to be 152 divided by 10 equals 15.2, which is the average. OK? Now, is 15.2 one of these numbers? No. The average does not have to be one of the numbers in here. OK? What's wrong? Trying to figure out what mode is?
the lowest and you subtract it from the highest or something like that? Or the middle? I forget.
You're close. We'll get there. We'll get there in a second. Okay. Here's one that you'll see something like this kind of frequently. No pun intended. You'll see something like this kind of frequently if you're trying to find averages. You might see a frequency distribution like what we did before, and you have to figure out the average. Okay, so let's say you have the following frequency distribution. Okay, let's say that we had 35, 37, 42, 58, 60, 62, 74. You don't have to write all these down. 78, 82, 84, and 95. Let's say these were grades on the exam. That would be bad, right? But let's say you had frequency of 1, frequency of 2, 1, 1, 5, 3, 4, 4, 2, 1, and 1. Okay? If you want to find the average of these numbers, really this is saying how many 35s are there? 1. How many 37s? 2. So don't you have to do 35 plus 37 plus 37 for the second one, plus 42 plus 58 plus 60 plus 60 plus 60 plus 60 plus 60, etc. But all we're really doing is multiplying this number by this number and then adding up all the ones down here, right? So we're going to get 35 for that one. Then we're going to get 74 when you do 37 times 2. And then it's going to be 42, because 40 times 1, and 58. Then 60 times 5 is 300, right? And then 186, let's see, 296, 312, 164, 84, and 95. So you add all these guys up, right? In fact, this is actually 1,646. And then what do you divide by? You don't divide by 10. You might think you do. You divide by the total of the frequencies, right? So you have to add these guys all up. There happen to be 25 of those guys. Question. Yeah, there's 11 there, yeah. Did I miss one here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, I have 11 there. Right? So the mean in this case is going to be 1646 divided by 25, which in this case is 65.84. Okay? That would be bad. Yeah, that would be bad. OK? So here's another way of writing this. OK? We can say that the mean equals, we know it's x bar. We also can write it like this. And don't worry about this Greek symbol for a second. Okay? What this means is that means takes the sum. It's called a Greek sigma is the letter. Means take the sum, means add up all the sums. Okay? And in fact, it's actually probably should be parentheses there. Because what you do is you add up all of the values times, the values. No, I was wrong. The values times the frequency, values times the frequencies, and then divide by the total number of values that you have. N is the total number of samples. Okay? So really, this means do exactly what we did. It means multiply the first one together, and then add it to multiply the second one together, then add it to the third one together, add it to the fourth one. That's what this actually means. Here, if I said take the sum of, let's say, well, this is not. We write it like this. Sometimes we will write it like this. I there, I equals 1 to n, or whatever. I guess don't worry about that. Don't worry about that. All it's saying is for all the values that you have to do this. Okay? Let me just write this other form just to give you a better idea. N equals 1 to 3. I'll make it x. X equals 1 to 3 of x. If I was to say that to you, what that means is add x's going from 1 to 3. 1 plus 2 plus 3. That's what this symbol means. I won't ask you that symbol, except maybe in this form. It says on your formula sheet, you have this. OK, it actually says, instead of saying this, it actually has this, of x divided by n. In other words, add up all the samples and divide by the total number of samples. It's the same thing with the frequencies, but you got to remember to do that. You got to remember to multiply by the number of the frequency times the value, and add those up, and then divide by the total values. Some people forget to do that. Okay? What's that? All right. Let's do another example. Let's say that, let's talk about exam grades again. I know, bad subject right now. Let's say somebody scored 50, 72, 41, 85, and 82. OK? We could easily find the average of that, right? But here's the question. What score does this student need on another exam to average 70%? Let's think about what that means. Okay? We have the 5 values here. If you're going to take another exam, how many values would you now have? 6. OK. So there's some value x, let's say. And we know that the average we want to get is 70%. OK? You want 70%. OK? So how would you, if you had these 6 values, how do you find out what your average is, what your mean is? 50 plus 72 plus 41 plus 85 plus 82 plus x divided by what? 6, because there's 1, 2, 3, 4, 5, 6, equals 70. And now we just need to do a little bit of algebra to figure out what x is. No, don't, Tony, don't give me that face. This is actually much easier than you think. OK.
Because if x don't have a value, then where do you get the 70?
Oh, I told you I want to get 70. So this student says, I better get a 70, otherwise I'll fail the class. This is what she has in all the other quizzes. Right? OK. This is what she has in all the other quizzes, or he, whatever. OK, on all the other quizzes. OK? And if it was a dog, this is what it has on all the other quizzes, right? OK. And we're just saying that there's one extra that we don't know yet, but we want to get 70%. We want to find out what grade. Because don't you agree that if you take a whole bunch of quizzes, if your last quiz can change your exam, can change your average. All right. All right. Now we just do this out, right? If you add all these up, these ones you can add because they're just numbers, right? That's actually 330, I believe. 330 plus x divided by 6 equals 70. Now that's an algebra problem that shouldn't be too hard to do now, right? What's the first thing we do? Multiply by 6. So we get 6 times this side, which cancels out the 6. And then 6 times this side, which gives you 420. So you get 330 plus x equals 420. Now what do? Subtract 330 from both sides, right? And you get x equals what? 90. So this student, in order to get a 70%, needs to get a 90 on that last quiz. OK? And that's how you'd figure this out. OK? And you guys will be able to do this once you get all your quizzes. You can figure out what your average is now and then what you need to get on the rest of the exams. All right? The one we're doing at the end of the class, right, that's going to be not x doesn't go here. It replaces, hopefully, one of the ones that's like the worst one. OK? The last one, I guess. OK? All right. OK, that's the average. You guys look depressed or something tonight. All right. That's how one of the things we average. OK. So we figured out the mean. Check. Okay. Let's look at the median now. The median, all you have to do here, arrange the items from smallest to largest and find the one in the middle. Now sometimes there won't be one in the middle. Okay, this is what Tony's remembering this now. Okay, so the first for the median, okay, what you do, arrange from smallest to largest. Okay, that's the first thing you do. Okay, then if there's an odd number, okay, pick the one in the middle. If there are an odd number of items, okay, the median is the middle item. No matter what, middle is the median. The middle item is the median. Okay. If there are an even number, what you do, okay, is you take the mean of the two middle items, because there's going to be two middle items now. Take the mean of the two in the middle. Okay? Pretty simple. 13, 13, 14, 14, 15, 16, 16, 17, 17, 17. What's the median? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's the average of the ones in the middle. What I normally do is I normally cross one off on one side, cross it off on the other side, cross it off on one side, the other 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 side. And if I'm left with 2, average the 2. So what's the median in this case? 15.5. Because 15 plus 16 divided by 2 is 31 divided by 2, which is 15.5. Okay?
Yeah. All right. So if you got the odd thing right, and you get the number out in the middle, then that's it, right? Or you still got to...
Yeah, that's it. You just grab the one in the middle and you're done.
All right.
Yep. Right? Let's look at this example. Here's the example right here. 12, 17, 8, 20, 10, 8, 10, 12, 17, and 20. What's the median? You can't just look at that and tell me. Once you rearrange it, you can. Right? But you got to do that. And I always mess these ones up. Right? What's the lowest one? 8. How many are there? 2. So I'm going to cross them out when I get to them. 8, 8. What's the next one? 10. And there's 2 of those as well, right? And then 12. And there's also 2 of those. And then 17. Also 2 of those. 20 and 2 20s. OK, now they're in order. Right? I guess there were just 2 of each. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's the median? 12. Did I do that right? So 12, 17, 8, 20, 10. 12, 17, 8, 20, 10. 8, 10, 12, 17, 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're right. Let's just say that one. There. Now it's 12. Right? Yeah. I know, but let's say there's only one. There. Okay. Now, if there actually, you know what? If there was 2 20s up there like before, it still would have been 12 anyway, because we would have averaged 12 and 12. You're right. Yeah. But with an odd number, you just grab the one in the middle. That's it. Okay. All right. Okay. So here's a little problem for you. Let's say you have. Were you writing this down? No. OK. Let's say I have a bunch of salaries. OK, 19,700. OK, 20,400, 21,500, 22,600, 23,000, and then 95,000. Yeah, you want that job, right? 95,000. What's going on here, if you said, what's the typical salary? What would the typical salary, well, when you look at that, what would you call the typical salary? I don't know. I mean, the typical salary, this is like the Bill Gates, right? That's like, right? Okay? So let's say it was like that. Well, this is like all the workers, right? And this is like the president or something, the owner, right? The typical salary is not the average. Because if you look at like Bill Gates and these 5 guys, the average salary is like, what is that? Like $100 million, right? Oh, you go work at this company. The average salary is $100 million. And you get there and they're like, OK, your salary is 22.6. This is why you don't want to do mean for some things like this. Because the mean doesn't make any sense. I mean, it makes sense in terms of, sure, the average is of 100 million or whatever, right? But the median is the one that makes sense. 1, 2, 3, 4, 5, 6. Take the mean of those two. Isn't that a more likely salary you're going to get? Right? Only one guy gets this. Everybody else gets these ones. Well, that's why the median can be kind of important. Okay? It's less sensitive to extreme values, like Bill Gates' salary. Okay? I guess if you did that at Microsoft, you'd probably get something weird like that. Like the average salary is like, probably $4 million a year. But most of the guys are not making $4 million a year, right? It's because of a couple at the top. OK, so that's the median and the mean. Median's a pretty easy one. Does the median have to be a value in the set? No, it's only a value in the set if there's an odd number in the set, in the sample. Right? OK. Finally, we've got the mode. Does anyone remember what the mode is? The number that's repeated the most. Yeah, that's a good way of putting it. The mode is the data value. I should say the data value that occurs most often. Most often. Okay, it occurs most often. And there can be more than one mode. Right? There can also be no modes if you want. Okay? 13, 13, 14, 14, 15, 16, 16, 17, 17, 17. What's the mode? 17. It's the one that occurs most often. Right? How about 2, 1, 3, 4, 6, 3, 5, 6? 3 is a mode. And 6 is also a mode. Because it happens twice as well. This is called bimodal, right? The mode is always in the set. You're not taking any means to get fractions or anything like that. The mode is always in here. But you can have more than one mode. OK? All right, any questions on that? All right, let's do this. Let's take a break and come back at 10 after.